This is a lesson to help with exponential expressions using the natural number e. So first of all, what is e? Well, e is called the natural number, and it's defined by 1 plus 1 over n raised to the n as n gets very large. Remember, this is not a number. This is a concept of huge numbers, as big as we can. So if we replace this n with 1, what is this? I don't know, 1 million that we've got there. So we've got 1 over 1, 1 plus 1 over 1 million raised to the 1 million, and you try to evaluate that. And they say, well, wait, that's not big enough. Let's try it with 1 trillion, or the idea, this concept of even bigger than that. Again, this isn't a number. I don't really like writing it this way, but I'm saying a huge, huge number here. And if we were to evaluate that, if we try to figure out what that is, it ends up that it's this digit, this decimal number that never repeats. It cannot be written as a fraction. It's not rational. And it's 2.7182818, etc. And typically we just kind of round it to just 2.72, and or leave it as e. And most of the time we just leave it as e, and that is the natural number. So on your calculator, there's 2 different places you can find this. And over here, right above the division symbol, you'll see a little blue e. And over here, right above what looks like ln, is an e to the x. Now, there's 2 other places where you might see the letter e. And one of them is here, and it's a capital E. That is not the natural number e. That's the letter of the alphabet. It's not a number. And there's another one above the comma which has double E, and that's something else. It has to do with exponents. So it's neither one of those 2. But these other 2 that we have here, this one here above the division, and this one down here above the ln, and they're a little bit different. One of them just says e, and the other one says e to the x, but you can use either one of them to evaluate expressions. So if I had an expression that says e to the 7th, and I want to use my calculator to get a decimal approximation, I could, on my calculator, hit second and then the e to the x, that's this button over here, and then I just hit 7 and enter, and I would get a decimal approximation. Or I could use the second and then hit this button right here, but then I have to hit the, you can't see it, but the little caret button right above it. So this method, you've got to hit an extra button, this one here. And remember, I'm very lazy, so I don't like to use this button because it requires me to hit the caret button and then 7 and enter. Now, the problems that you really have in your homework have to do more with graphing. So I want to have you recall that all exponential functions, we find these 3 points. When we've got y equals b to the x, we know that when we plug in a 1 for our exponent, we would get b, whatever the base is. If we plugged in a 0, well, anything to the 0 power is just 1. And if we plugged a negative 1 into this exponent, negative 1 means take the reciprocal of the base. This will be 1 over the base. So if my base was 2, I would have 1, 2, 0, 1, and negative 1, 1/2. If instead my base was 7, well, then over here I'm going to have input a 1 and you get a 7, input a 0, you have a 1, and a negative 1 gives you 1/7. If I had 1/2, well, I plug in a 1 to that exponent, and 1/2 to the 1 is just 1/2. 1/2 to the 0 is 1. But what about negative 1? Well, it's the reciprocal of 1/2, which is 2. Now, what we're here for, though, is to look at exponentials with base e. So if it was base e, it follows the same rule. If it was e to the 1st, we'd have e. And if it was e to the 0, we'd still have 1. And if it was e to the negative 1, we'd have 1 over e. And that's exactly what they are. But to graph, we kind of need a decimal approximation. So we plug it into our calculator, and we find that we have these decimal approximations. So I put those points on my graph paper, and then I connect them, and I have the graph of that exponential function with the base e. Don't forget that there's an asymptote at y equals 0. So what happens when I have y equals e to the x plus 2? Well, just like any function, I'm adding to the x, which means I'm going to move it to the left. So this means I'm going to move this graph. I would take all the points on this graph and move them 2 units to the left. Move all points 2 units to the left. If I had y equals e to the x and then adding 2, so I'm adding 2 after the exponential expression, it means I'm going to move the graph, including this asymptote. Everything is going to go 2 units up. So this asymptote would no longer be on the x-axis. It would be all the way up at y equals 2. And lastly, not lastly, but I have 2 more to show you. If this one was e to the negative x, when you negate the x, it means to reflect over the y-axis. And so, as you see, this function here, it's going up this way. But if I were to reflect it over the y-axis, it would look like this, and it would be a decreasing or a exponential decay problem. And you'll notice it would be the same thing as if I had y equals 1 over e to the positive x, because this negative exponent means flip the base, and so I could look at it either way. The last one is where you're negating the entire function. You're negating e to the x. Well, that means to reflect over the x-axis, so all of the points that were up here will now be down below the x-axis, and we have something that looks like this.